Hello, welcome at the ECSS Symposium. Welcome here in Ruhpolding in southern Germany in Bavaria. My name is Dr. Björn Zimmermann. I'm here at this wonderful place and to show you some specific applications about our systems, our treadmills. And here with me is also my colleague Titus Remppel, my colleague, or actually our customer, Michael Veit. He is the leading sports scientist at this place, at this Olympic training center, or at this satellite of this Olympic training center here in Ruhpolding. He is head of sports science. He's typically doing all the tests and training recommendation to the athletes. And also we have our athlete here, Lucas Bögl. And now I will hand over for a second to Titus.
Thank you very much. Thanks for the brief introduction. My name is Titus Remppel. I work for the company Cortex, and we got invited to this beautiful surroundings here in Ruhpolding to use this facility with our equipment and to have a bit of a session today, really, with Lucas on the treadmill, huge treadmill, the Beast. Beauty and the Beast was the play we started. So Beauty is the little device he's wearing, and the Beast is the big treadmill we're going to use for a spirogometry on a very large-scale treadmill for CPT testing.
Yeah, we can go on.
Okay.
Titus will start with a brief introduction or a further introduction to the company. Then I will take over and explain some specifics about our systems. And finally, for sure, you will see the Beast and the Beauty in action. We will do some roller ski testing setup here in this lab. Titus.
Thank you. Okay. Thanks, Michael. Okay. So welcome again to the Satellite Symposium Beauty and the Beast here at the ECSS 2021. Unfortunately, we are still in online mode. Next year, hopefully, Sevilla will take place finally. But as of today, we are online. Let me quickly give you a brief introduction to the company of Cortex. I'm pretty sure, as we're all sports scientists here, most of you, if not all of you, have heard of us before. We are a company based in eastern part of Germany, in Leipzig, and we've been doing this quite a while. We manufacture spirogometry equipment. We do mobile and stationary test equipment. We do actually work now in the market of spirogometry for over 30 years already, and hopefully more to come. We have specialized in the niche market of mobile spirogometry testing, and that is what we are going to present here today. We do export into every possible angle of the world, and let me say beyond as well, because what we have here in these three slides, as you can see, is a ski mountaineer hiking up a glacier. In the middle, we do see a full stall backflip by a paraglider. And on the right-hand side, for those of you who haven't visited the symposium in Prague, this is Dr. Alexander Gerst flying away on the space station, measuring with the Metamax. So enough of that. Let me quickly touch base with you guys in terms of spirogometry. Spirogometry is very interdisciplinary. So a lot of people can benefit from the use of spirogometry, be it a doctor, physicians, preoperative risk assessment, people from occupational health, and obviously also sports science and sports medical professionals. I do not want to go into too much detail here because I'm pretty sure that everybody has had a lecture on performance testing in their studies already. However, what I'd like to do is get a quick focus on what we actually get out of a spirogometry test, if you like. So what is the essence of a spirogometry test after performing one? It is basically assessing the cardiopulmonary fitness. So what everybody, or most of you people know, is the VO2 max. It's a very simple value that we can get from a CPT test. However, it's subject to certain limitation and changes depending on the ergometer you use and the surroundings that you're actually testing under. It is also great for detecting limitations of performance and obviously getting rid of them, and to have a look at development. So we test somebody before a training, then we do a training load of X months, and we test him again, and we have a longitudinal check for the change in performance. Obviously, we can use it in a more medical sense for differential diagnosis. We're going to skip that today. And we also have the chance, depending on the style of protocol you're using, to assess the ventilatory thresholds, number 1 and 2, and obviously to deduce heart rate zones for training. So depending on the style of ergometry that you're running, you always try to be as close as possible to the sport that you're testing for. So in this case, Lucas is a performance skier. He's a German professional cross-country skier. Today we'll test him in freestyle, so skating, not the classic style. And obviously, this is a great idea to test somebody as close as possible to their actual sporting performance. So cyclist goes on the bike, runner goes on the treadmill, and a skier obviously can go on a very large-scale treadmill here as we are testing today. So enough of that. What we're going to do now from my side is I'm going to prepare Lucas for the live test. During that time, I will hand over to Björn. He will take over and talk a little bit more about the beast and other aspects of the treadmills that we have from HP Cosmos.
Thank you, Titus. I'll just come a bit closer to you. Okay, so while Titus is preparing Lucas for the live test that we're going to run in a couple of minutes, I will give you some quick overview about our, we call it, from a business point of view, we call it markets, but it's actually your application in a research setup. So ECSS means, European College of Sports Science for sure, but your profession and your job is either being a student, being a professor, being a lecturer, or being a researcher or a, let's say, lab specialist. And for that reason, we do have different treadmills for research. And our treadmills, you can actually see here a little of the bandwidth. We have small size treadmill. Small in this case means it's actually a lot bigger than a gym treadmill. And we have a very large treadmill for a very specific application, roller skiing. You will see that. So the most of our treadmills in worldwide universities are smaller than this, but could be a size like this or slightly bigger. A typical application for our treadmills is doing a performance test, spirometry, lactate testing, or very specific research for downhill running, uphill running, sprinting, and specific applications like this. As I said, quite often, our treadmills are being used for performance testing. That means the athletes will perform a ramp test or a stepwise profile until they are fully exhausted. And this is not just the case in universities, also in very professional sports. They're doing a performance test either once a year or twice a year. So for example, in the off season in soccer, so in football, this is the case in the summer break, actually, right before the next season starts. And even in this year, we have some examples, what you see, some examples of professional clubs from the German Bundesliga, but many other clubs are also, doing a performance test as well. So professional sports means now it's very research-based that the athletes will or have to perform a test in order to find their weaknesses or strength. So those examples that can be seen here is from Eintracht Frankfurt, for example, or Red Bull Leipzig, and many other clubs as well. Just recently, Lionel Messi in his new club has done a test as well. So beside our treadmills for performance testing, or let me mention a very important point in case of a performance test, is what you see here, a safety arch. That's a safety feature. The same here for the oversized treadmill. This kind of safety feature for us is important, and also the trainers and the athletes, it's very important to get the necessary safety. So in a performance test, we will not exhaust Lucas today completely until he is getting a blackout. But in a performance test, sometimes a blackout could happen by the end of the test. Athletes will have throwout, they're puking sometimes, or they're getting dizzy. And then there's a risk that they fall off the treadmill. And when falling off the treadmill, it means, some could be an accident at the end. And this is what we're gonna avoid. And therefore, we have a safety arch with a harness system. This is very important in a performance test, but also in specific, let's say, speed training, overspeed, high-speed training, also in rehabilitation. It's very important. Besides those, I still consider this as a standard treadmill. I mean, in our range, a standard treadmill. We also have oversized treadmill that are bigger than this, but still smaller than this. So our models, the Venus or Saturn oversized treadmills, I call them multi-purpose treadmills. Multi-purpose means they're very versatile. You can use them for many applications, for different applications you've never seen before maybe. So for sure, standard application on a treadmill is 90%, 95% on those oversized treadmills is still running or even sprinting. On the very big machines, you can also do specific, special applications, such as cycling. So just consider, put a real bike, could be a mountain bike, could be a racing bike, put this on a treadmill, put some speed to the treadmill, up to 80 kilometers per hour, for example, and in incline. This is very specific because the athletes can use their own bike. They have a real feeling behavior, so in contrast to a stationary bike ergometer, they can use their own bike with a swinging and the right feeling. And our athletes or the trainers appreciate also the fact that they can control the environment. That means they can control the incline, the angle, the pitch, the speed. So, for example, just in preparation for Tour de France, they can predefine those specific tracks into the treadmill. So very good in preparation for the training. Another specific application is the use of a wheelchair or a handbike on the treadmill. Right now, at this time, the Paralympic Games are going on in Tokyo. You will see many athletes sitting in a wheelchair. Could be either in rugby, could be in tennis, in badminton, or racing, speed racing, or even marathon in a wheelchair. And those professional athletes, they're getting tested as well. For sure, they need to get tested in order to improve their performance or even improve the material, so the wheelchair itself or the handbike. Those devices are getting improved very technically, for sure. And the oversized treadmill, the Saturn, HP Cosmos Saturn in this case, is a perfect device to provide this specific environment, to put a wheelchair on a treadmill. And at the same time, it's also, again, very safe. The wheelchair is stabilized in the, let's say, straight line forward direction, but it's free in the fore-aft positioning. So the athletes have to perform at the end. Another specific application on our bigger treadmills is skiing, for example, in a classic style. Classic style means the skis are in parallel mode, and this can be done on the oversized treadmills as well. But on this specific treadmill that I'm talking about, it's not possible fully to do the skating, cross-country in skating style. Therefore, the athletes will require much more space because of the big demanding movements. And for this reason, we do have here the Beast. This is our biggest treadmill and probably the biggest treadmill on the world. The Beast is just our internal name. Actually, the product name is the HP Cosmos Saturn 450-300 RS. This is the actual name of that beast. Just to give you an estimation or about the dimensions, the Beast, the size of the running deck is 4.50 meters by 3 meters wide. The total weight of the system is 12,000 kilograms, 12 tons. That means what you see here is actually just like the tip of an iceberg. The most of the treadmill is underneath the floor. So it's an elevated floor here, 1.30 meters below. This is the structure of the frame. Yeah, it's quite heavy. It's not easy, and in a typical situation, the room or the building is built around the treadmill, not the other way around in this case. So we put the treadmill maybe in a pit or on a concrete area, and then the rest of the building is or the room is built around it. This is yeah, always not just fun, but very technical, very complex installations, but we are expert for this. And an installation, as what you see here in Ruhpolding, is existing in many other professional institutes worldwide, for example, in Austria, in Hochfilzen, in Jablonec, in the Czech Republic, in Falun in Sweden, and some others. So very specific devices. This is not a gym equipment anymore, for sure. This is especially designed for biathlon, for cross-country skiing, for winter athletes. Yeah, what else to say to our oversized treadmills? Yeah, as I said, I call them multi-purpose treadmills. In an Olympic training center, they are used for 90%, 95% in running. Very large space. The athletes are very free in their movement, in their position. They are feeling not restricted. And you can use them for other applications, specific applications for special athletes as well. Yeah, beside our treadmills for performance testing or other research, we also have very sensitive treadmills. Sensitive means we have treadmills for biomechanics. Treadmills with built-in sensors. For example, yeah, we have mainly 3 technologies that we can build in the treadmills. One system is called the Optogate from the company Microgate from Italy, our partners. And this is considered as an optometric diagnostic system. It consists of many, many light barriers. And just by interrupting those light barriers, the system knows where your feet are and the distance towards them. This is one system. Another system is from our German partners, the company Zebris, and this is pressure distribution. So that means underneath the belt, underneath the deck, or in the deck underneath the belt, we will put some pressure distribution sensors in. So a full deck, that means depending on the size, it's between 5,000 and 12,000 single sensors that measure the vertical pressure or the vertical force calculated underneath, and also within a few seconds you get step length, contact time, and the symmetry for sure of the applied forces, left foot, right foot. Very accurate and let's say very widespread in different universities. And our flagship in biomechanics is called the Gaitway 3D, the HP Cosmos Gaitway 3D. This treadmill consists of load cells. Underneath the corners, in the front and in the back of the treadmill, there are load cells. 6-component force measurement, that's the topic. And it's pretty much like a very large force plate that you know. And that means in running or in walking, the Gaitway 3D measures the ground reaction forces of the single limbs, left foot, right foot. And yeah, this is a pure research device. It can be used for other testing situations as well, like a CPAT test, but mainly this device is used for measuring ground reaction forces and the calculation and the measurement of many gait parameters, running parameters, vertical impact, braking impulse, and there's a long list of torques, moments, and specific parameters that can be measured with the Gaitway 3D. As I said, the Gaitway 3D is our flagship in biomechanics. In biomechanics, it can be also combined with other typical devices that are in the lab, such as motion capturing, so like infrared or 2D camera systems can be synchronized and combined with the gateways 3D. And this is important for the calculation and the measurements of inverse dynamics that are, let's say, state-of-the-art in nowadays biomechanics. It can also be combined with additional sensors such as IMUs, so accelerometers, gyroscopes, or high-speed cameras, as I said also before, or EMG. Like what you see is a combination of the Gateway 3D in Noraxon's setup. The company Noraxon is providing actually EMG devices, and those can be combined fully with the Gateway 3D. So a full setup, almost no preparation time, and tons of data. You can process the data in the software, but you can also export the data as a raw format and do whatever you like in MATLAB or Python or Excel. This is the Gateway 3D. Yeah, our treadmills, coming back to, let's say, what statement is valid for all our treadmills. All our treadmills are very durable. They're very solid, very rigid. And the durability, just as an example, the athlete Florian Neuschwandner, for example, in the beginning of this year, he has a world record attempt of 100 kilometers on a treadmill, and he succeeded. He won, he broke the world record, and the system was just fine over the whole distance. But Florian, he had some hard times, but he beat the time by a couple of minutes. So he did a very good job. And our treadmills are also durable in very specific surroundings, in very specific conditions. So we also have customized solutions for our customers to put a treadmill in a climate chamber, for example. In this example, you will see a climate chamber. This is in Italy, Terra X Cube, and this is going down, in this case, down to minus 39 degrees, so quite freezing in there. And on the other side, plus 40 degrees. The chamber itself can go higher or lower, but as you see here in this very specific condition, the treadmill is doing a great job. It's specialized, it's customized. It's not a standard treadmill in this case anymore, because a normal treadmill, any treadmill, put a gym treadmill in a climate chamber and you will see rust within a couple of days probably because of the moisture in the room, the condensation of the moisture that will simply destroy a normal treadmill. Yeah, before we will go over to this treadmill, I'd like to show you our new user terminal. I will go the sign to Titus that he will start preparing the athletes, because in a few seconds you will see the live demonstration on the Beast, on the oversized treadmill. And I'd like to show you first, before, our new user terminal. This is a treadmill. It's called the Quasar model treadmill. And this Quasar treadmill has now, as an option, a new control terminal, this one. And this is what we call MCU 6, Motor Control Unit 6. The motor control unit is just, let's say, a hidden technology built in the treadmill to control the treadmill, to elevate and to increase the speed of the motor and so on. But what we see here at the MCU 6 is also our new user interface, and we will change the camera for that reason. Our new user interface, the software. So it's a big touch screen now, more than 10-inch of a screen, and we still have some haptic, some real buttons, because when you are sweating, you need to feel what are you pushing. Otherwise, you can also use the screen here. So like a normal treadmill and like our treadmills before, we have different modes, like call it quick start, and we have profiles. Here in profiles, not sure if you can really see it, we have some implemented standard profiles like interval runs or tests the UKK walking test, the Conconi test, a Gardner test, standard for endurance testing, many other tests as well. I'd like to show you here how it looks like in the live mode, or let's say in quick start mode. What we improved and what we implemented now is a very, let's say, the visibility, what you see. We have the graphs, in this case, the green line, not sure if you see it, the green line represents here the speed. There's a line for heart rate, there's a line for elevation. And what is also new is down here, it's a step count. Simply speaking, it's a step count. It counts my steps while walking here on the treadmill. And at the same time, I will change that for a moment. And at the same time, it's calculating also the step length. Step count, step length, and down there is the cadence. So how many steps per minute? The cadence is a very crucial factor in the analysis or maybe in the improvement of a running technique. There's an optimum. There's an optimum cadence that someone can run. It can be adjusted. So, and the cadence is directly affecting, if I'm doing some smaller steps, cadence is going up and the steps are getting smaller. All right. Last but not least, before I forget to mention, there's also a new plot. It's called point carré. That's a visibility or a mode about the heart rate. And the point carré diagram is giving here the heartbeats on X and Y axis and is giving some plots about the single heart rates. And in an ideal world, in an ideal condition, you will see like a small line here instead of a big cloud. Alrighty, now time for Titus, time for Lucas to run on the beast. All the best for you. Please survive. Thank you.
Okay, I got the green light, so I hope my microphone is open now. In the meantime, while Björn explained the pretty new feature on the HP Cosmos, I got our athlete ready, up and running. I applied the Metamax on his chest, and he's now happily skating away. Just for you guys to know, we are now skating at a very slow pace because this is just a warm-up phase, really. Talking about warm-up phase, Lucas just told me he had 3 hours of training session this morning already, so he's pretty solidly warmed up, which allows us to skip the warm-up phase for now and go straight into the ramp protocol that we have chosen. As you can see now, he's skating really easily. So he just pushes one arm stroke to one foot off, push off. The higher the speed will be, so, you can see some changes in technique as well. So for now, I'm going to skip into the ramp protocol. It's not an all-out test, as I said, because Lucas has been skiing 3 hours already. So moving on to increasing now speed and elevation of the treadmill to a certain amount of speed. We'll see how far Lucas is willing to go and how much time we actually have. Björn, about the beast, I mean, he's skiing now really easy and on 2.5% of elevation. Just from my understanding, how high is the beast actually able to tilt up?
Actually, the beast has, per standard, also negative inclination. That means in this direction, he can also go downhill at -4%. And it's uphill to 20. I'm getting signs from the side. yeah, more than 20, simply speaking, more than 20, 25% going uphill, and that's very steep, actually, yeah, so...
It's pretty impressive, but we agreed on not pushing Lucas to all-out conditions today. So now let's have a look at the spirogometry data that we're actually receiving. We connected the Metamax with the long-range Bluetooth antenna, which usually has a range of more than 1,000 meters as a good line of sight. Obviously, 10 meters indoor or 5 meters indoor is not a problem at all. We also equipped him with a heart rate belt that is sending via Bluetooth to the Metamax and then to our software. We can see that he's with a heart rate of 115, still in a very easy state. Pre-training, load or not, that's very relaxed still. His current oxygen uptake is close to 2.5 liters, so 2.3, 2.4, with a relative oxygen uptake, so divided by his body weight, of 35 mils per kilogram. We are now currently at a speed of 11.8, so coming up to 12 kilometers an hour. What you can see here in the black frame, that's the respiratory exchange ratio. That indicates the amount of oxygen we take up and the amount of CO2 we exhale. If you divide one by the other, you get the respiratory exchange ratio. With a ratio of just under 0.8, we can confirm that he is still in a very easy state of his exercise, of his physique, really.
Titus.
Yes.
May I ask a question in between?
Sure.
Just before we talked, or I talked about Paralympics. Paralympics, I've seen those very specific racing wheelchairs, or call it handbikes. The athletes on a handbike, they are almost lying and doing all the job with the arms. Can you use also this device with? Yes, what I understood, you can use it outdoors. Can you use it also in a different mode, like what we see it here, putting it to the chest, putting it to the back, depending on the sport specifics of what you need?
What you're referring now to is these athletes that are in a really supine position where we have no real chance of supplying the device to the back. So it would be easiest, like we have it today, wearing the device on the chest. We also do have a back carrying system. So imagine you want to test a time trial athlete who's lying on his aero bars like this. There is no room for a device, so you best chuck it on the back. Or if you are in a, say, a regular lab situation, not with a giant beast, but with a regular HP Cosmos Quasar, and you have a measurement station, you can also use the Metamax in a stationary solution. So we simply prolong the data cable of the volume transducer and also the Nafion tube that we use for sampling the gas. You prolong that to 2 meters, and you have a power supply for the Metamax, and you can simply measure with the device in a real stationary situation for a whole day. With athletes with special needs, it's very interesting because obviously we cannot use our regular standards. For example, if you test a paraplegic athlete or an amputee and you want to do a lactate test, obviously lactate values will be completely different because a large portion of the muscle that usually produces lactic acid is gone or is inactive. So you cannot really use that. Where we see a lot of athletes actually using spirogometry for their performance diagnostics. All right, let's have a look at Lucas. He is still happily skating away at around about 15 kilometers an hour, so 14.8 and rising. Heart rate has risen to 132. And the elevation of the belt is now 3.5%. So the steeper, obviously, we rise the belt, the more intense the workout for the test subject on the belt will be. Now, if we talk about skiing, we would usually, if we do a proper performance diagnostics, we would probably use a different protocol where we increase the steps either after a certain amount of time or mix it with lactic acid sampling or use a different type of mixture of increasing the speed and increasing the elevation to get those values that we're looking for. For runners, recreational runners on smaller type treadmills, quite often we see ramp protocols. In clinical use, the ramp protocol is the standard. in more sports science or sports-related high-performance sports, we quite often see people who use step test protocols because they want to combine it with secondary parameters such as blood pressure, lactic acid, blood gas analysis, you name it. All right, what we can also see here is that Lucas is pretty depleted on his carbohydrate storage because we see a very high fat acid metabolism and it's not really moving very much. Well knowing that he has done 3 hours of training already indicates that his carbohydrate metabolism would be rather low. So in the picture that we're showing here, we have the orange graph, that's the fat metabolism, and the red and the blue graph is the ventilatory equivalent of oxygen and CO2. Ventilatory equivalent stands for the comparison of your ventilation, so your ventilatory system, and that divided by the oxygen uptake. So in other words, how efficient are you in getting the oxygen into the system? So how many liters of air do you need to ventilate to take up 1 liter of oxygen? That will be very interesting if you do threshold calculation, obviously, as we can use this in the classic panel 6 of Wasserman. We're looking at Lucas, he's still, if he could, he would give me a thumbs up, is that correct? Yeah, okay. Talking about threshold calculations, obviously a lot of people are accustomed to a different look in the software, and that will be the classic 9-panel plot. In the 9-panel plot, you have all the different graphs that we have known for several years and decades now, where we combine the gas exchange measurement and the ventilatory measurement. Some panels are pure gas exchange panels, some panels are mechanical panels. In modern software, we always encourage people to tailor the look of the software to their needs, really. In this case, I have made up my screen of several different single-channel informations and a couple of graphs that I would like to look at.
Yeah, Titus, in my previous slides when I talked about performance diagnostics and those treadmills, I had those slides from Eintracht Frankfurt and Red Bull Leipzig.
Yes.
I noticed, just by contrast now, and I hope it was a Cortex system that was shown there.
They all are.
In this case, I noticed that those masks they're looking a bit different than
yes.
those masks here. You see it here on the other camera, maybe Lucas, in a close-up. Is there a difference in the mask system?
Indeed, there is. We have 2 different ways of operating our spirogometry systems. I'm playing around here the whole time with a disposable turbine. Long before the pandemic situation covered the whole world, we started using disposable turbines for our CPT equipment. Obviously now it's more important than anything else. With the disposable turbines, we do not have to clean the ventilatory system after being used. Because obviously if you have very small parts that are moving, you have to put them into a bucket, you have to wait. It's always a bit of a time issue if you have a large soccer team that you have to test in a row. So that it gives you several advantages. Obviously, hygienic reasons. Secondly, is a timing aspect. You do not have to wait until your turbine comes out of cleaning, and you do not have to have several, obviously higher in investment, regular turbines that you can then use one after the other. We have most of the systems that we have delivered last year are actually going out on a disposable turbine.
Is that like an argument nowadays, in this specific time of COVID-19, to clean all the systems?
Obviously, there are different solutions that we can produce. There is the possibility, like other manufacturers do that as well, that you can use a filter. But the filter always influences the measurements slightly. Not so much the values, but also the feeling of the athlete, because there is a bit more dead space, and therefore there's more warm air behind the ventilation system. All right, we're looking at Lucas now. We have reached the 20-kilometer mark, and we are at almost 5% of elevation. And as you can see, he is still using the same technique, but it's much more dynamic. So comparing 10 kilometers an hour to 20 kilometers and 2.5% of elevation to 5% of elevation is quite a large difference just by looking at the athlete skiing away. We've reached a heart rate of 175, and what we can also see is that our fat metabolism has now decreased completely. So that is for us a good indicator that our test subject has actually passed through the first ventilatory threshold and is now building up lactic acid more and more the more we keep him going. So if that is okay, we have now 11.5 minutes in the test scenario. Lucas, es wird jetzt langsamer. We are finishing the test, and we give him a recovery speed of 12 kilometers an hour at a 2% elevation.
Very good.
So really easy skiing for him, and just recovering, which is also a very interesting aspect if you have a look at the spirogometric values post-test scenario. So how heavy did we load our test subject, and how quickly does he recover? Obviously, this was not an all-out test for Lucas. He could have gone much higher. For us recreational skiers, that is the maximum we can go, right? For professional sportsmen, not even a challenge. However, we saw what we wanted to see. We see clear depletion of the fat metabolism. We saw an easy-to-detect ventilatory threshold if we look at the increase of the VCO2 in the exhaled air in comparison to the VO2. What I particularly like about performance sports athletes is the decrease in heart rate. He was close to 180 when we stopped the test, and just seconds after we're finished, he's already back to his regular basic workout routine, under 100 or close to 130 already. All right, while Lucas is finishing his recovery, I can hand back the microphone to Björn. First of all, I want to give a big shout out to our athlete because that was good effort. And he can still wave. For me, this is incredible. All right.
Yeah, thank you, Titus, and absolutely, thank you, Lucas. Great performance. Yeah, my style or my preference style of skiing is more downhill, so there's no reason for me to do it in inclination or over a long time. This is not my sport, but very good, and always safe here. Yeah, I need to try this as well. So, just they're finishing, they're dismounting all the safety gadgets now. This was a nice overview about the performance test in this specific application, roller skiing, cross-country skiing and skating style on a very, very large treadmill. Yeah, this was what we called this session, the Beauty and the Beast. Maybe Lucas can come for a second to show the mask. Keep it like it is. Just one second to the camera. The system. This is the performance guy and the beauty, and behind it's the beast, the 12-ton treadmills, the treadmill. Thank you, guys.
Thank you, Lucas.
Thank you, Lucas. Thank you, Titus. Thank you here, the Olympic Training Center in Bavaria, in Ruhpolding, for being here to represent everything, to showcase very modern and state-of-the-art performance diagnostics. Yeah, please feel free to contact us. Again, my name was Dr. Björn Zimmermann. My email address is björn.zimmermann@hbcosmos.com. Feel free to reach out to us if you have any questions, if you need any answer to your research topic that you have in mind. Titus?
Well, now it's on me to have the last words. Thank you very much for listening, for watching this little satellite symposium here on ECSS. To give you my email address is titus.remppel at cortex-medical.com. We will have that signposted on our material that you can watch online as well. Thank you very much, Björn. Thank you again to our athlete, and I wish you a very good time at the Congress of ECSS. And hopefully see you next year in Sevilla. Thank you.
Is it still Sevilla?
It is still Sevilla.
Okay.
Apparently it is still
It never skipped.
Yeah, no, and they skipped Glasgow, and now it's again
I'd
Sevilla.
like to go to Sevilla.
Let's see.
It's much warmer than here.
Yeah.
Thank you, guys.